Otherwise, we'll pop on to Liliana, who is coming down to talk about regional water supplies in mining regions. You'll see her slides coming up there. Here we go. I'll pop you the microphone. Okay, thank you, Liliana.
Thank you. Well, hello, I'm Liliana Pagliero. I work at SWIMI here at SEMAI, and I will present our project that's called Regional Water Supply in Mining Regions. Just to say that the work that was done in this project allowed us to prepare a proposal that was presented to a partner, industry partner, and it was granted a project for 3 years, fully funded for about 12 researchers. So that's a very good news and output of this project. The case study is the Atacama region in Chile. So what's this?
Just click it in there and then it should advance.
Yeah. So the motivation of this project is that most of the mineral deposits are located in arid regions. Here there is a map of the more important mineral deposits and a map of the climate regions in the world. In orange and yellow we have the arid areas, and we see that an important part of these deposits are located in these areas. A great challenge to access these deposits are the lack of water. An example is the northern of Chile, where you can see a lot of, it's an area rich in mineral resources, but also a very dry region. In fact, we have there the Atacama Desert, which is the arid desert in the world, where it rains only 1 millimeter per year, less than 1 millimeter per year. So the situation for the northern Chile, as you can see in this graph, where we are comparing the water availability with the water demand, we see that in the north of Chile, the demand is way bigger than the water availability. An extreme case is the Antofagasta region, where the larger open pit mine in the world is located, the Chuquicamata mine. In this scenario, desalination of seawater appears as a solution. In fact, the Chilean government is pushing towards desalination. There is a law in project now that will require all mines above a certain size to go only use salinated water in an attempt to lower the burden to the continental waters. Oops, sorry. Yeah, sorry. What did I do?
Sorry. Just stay away from that part right there. That's the best thing to do. Screen sharing is paused. Resume share. There we go.
Okay, so how do I go back one?
Actually, if you want to just hit the arrow on there, this might work, hopefully.
Sorry. Okay, so this is Antofagasta region, the region that I was explaining before. And the desalination development is already happening big time there. There are several mining companies and a potable water company that already invested in desalination. There are at the moment 10 desalination plants operating, plus 8 more in project. There exist pipelines, more than 2 kilometers of pipelines to bring the water from the sea towards the destinations. They're traveling up to 180 kilometers with an altitude difference of more than 3,000 meters. But as you can see, this development is only individual supply solutions, and it's a fractional system. And just common sense says that this is very inefficient and not optimal. So this gives you the motivation to look at what if a more integrated water supply system happened. So the motivation, as I said, is the opportunity to explore an integrated water supply system that optimizes the use of the resource and boosts the regional development. So the objective of this project is to develop a visual tool to explore and optimize an integrated water supply, to explore the benefits of this integrated approach, and to use the tool to generate dialogue between the government and the industry towards a most efficient use of the water. We are going to implement this project. We implemented it in the Atacama region, which is the next one south, as the one that I was describing before. That is a bit in better shape than the previous one, but nevertheless very stressed in terms of water. And also the desalination development is not so big there yet. So the Atacama region has a very important mining presence. You can see there is mining throughout the area. The red spots are mines with a bigger size. They produce copper, molybdenum, gold, silver, and iron. And the sources of water at the moment for the copper mining industry there is mainly relying on surface water and in groundwater, but already 20% of the water comes from desalinated water. There are at the moment 3 desalination plants operating that bring water to those 3 mines that are there in green in the figure, and there are 3 more as projects. And what makes this region very interesting is that there is a private project called the ENAPAC project, where they want to build a desalination plant that will produce 1,000 liters per second, powered by a solar plant, and a reservoir that's located in the green spot there that will store 600,000 cubic meters to supply water for the region, initially only to mining, but also to other users. And there are 7 mining projects that at the moment are at risk because there is not enough water to their development. So with this information, and we work in a spatial optimization tool. This project it's been going on in Sweden for some time now as a side project, and the funding of the complex ore bodies allow us to really put effort into it. So we aim to, with this tool, to calculate the least costly path to bring water from a source node to a demand node. We are going to use here in this presentation as an example the ENAPAC reservoir as a supply node, and the demand node is composed of 28 active mines and the 7 that I mentioned earlier that are in as a project. These mines were selected by the ENAPAC people as a possible clients for them. But the really core of this calculation really is how we assign cost, and we try to minimize it. So the obvious one is the energy cost that has to do with the topography. How much energy will cost to bring water from point A to point B. So with a topographic map, we obtain the slope of each cell, and we rated the slope as to 10 being the most costly and 1 being the least costly. So, but when we wanted to see what if we incorporate somehow the environmental cost. So we did this, we are trying to do this incorporating restricted areas into the region. So we searched into the databases of the government, and we came up that the Chilean government has these classifications for restricted areas. And we looked into the law behind it and also compared with other international standards. And we came up with a priority that gives a cost from 1 to 10, being the 10 the most costly area to pass through. For the region, this is how it looks like. Those are all the restricted areas of the region, being the red ones with the more costly ones. So the cost raster, where our tool work is based on, is calculated from these layers. So, and it could be only energy cost, it could be only environmental cost, or a combination of the two that we can work and play with. So the tool is based on ArcGIS tools that are readily made. So we enter as input the nodes, the source nodes, the demand nodes, our cost raster, and we obtained the optimized routes from bringing water from the ENAPAC reservoir to each of these mines there. At the moment, the tool only calculates its one path from the reservoir node to the mine, but you can really see here that clusters of mine could benefit of sharing infrastructure. So this is the first seed that you clearly see from this kind of optimization. We can also know now the energy cost that will cost to bring water from A to B for each of these mines from that point. And we are, the next step of the project, and there is a PhD student working on it, is trying to also calculate the environmental cost that this could signify. With this work, we prepared a proposal, and the proposal basically says that we want to go from what happens in the left right hand side of the slide, the meaning a mining company only looking after themselves and investing in money in water desalination plants for their use, to a more integrated approach where all the water users could be integrated and all the water sources could be integrated into a regional system. So the expansion of the work that we are going to be pursuing in this project is to include other sources of water, not only the desalination, but surface groundwater and wastewater, to include other water users, not only the mining, but the communities, agriculture, and other industry. We're going to go and engage with all the stakeholders in the region. We need to do a review on our spatial optimization to see if we can improve it. And because we are going to be dealing with more than one source of water, we need to work on a network optimization after our spatial optimization. We are looking at also include the seasonality of both the water sources and water demand, because if now we are including surface water, for example, there's a seasonality there in their availability. The same with the water demand, for example, communities or the agricultural stakeholders. We are going to also be working in a white paper or feasibility study to see what are the challenges, especially in the Chilean context, that could be prevent the development of this kind of approach. And we are going to be working in two tools. One, a more comprehensive water planning tool based on GIS that will integrate all the information that we have and really work to plan a better system for the region. And also, we are going to have a more simplified public accessible tool for most of it for educational purposes. Just an example of what we are aiming with this is, for example, this is the results in the left-hand side for just using the energy cost when we are trying to convey water from that desalination plant to the mines. And this is how it would look like if we only see the environmental cost. And there in the right-hand side, we can see that there are differences, and this could generate some dialogue and some trade-off with the stakeholders and some very good outputs for the region. So as you can see, very exciting project. And well, it's been, because it's a long-term project, it's a lot of people that have participated here. So this is the people who are participated in the project. Thank you.
Here you go.
Oh, yeah. Thank you very much, Liliana.
Can you hear that? Yes, we can. You're catching up a lot of time, so I think we can probably have time for a bit of a question here. It's a fascinating topic. I guess often people tend to think about water issues, about solving at the technical end. You're reusing your process water, etc. But this optimization of water distribution networks and the policies that are needed for that is fascinating. So, is there anybody here or indeed online that would like to ask a question of Liliana? Oh, there's one over here.
Hi Liliana, great talk, really interesting. Are you taking into account the capacity of the desal plants as well with your analysis? So as you incorporate more and more users, will the desal plants be able to cope with it?
Well, because it is an integrated approach, once we have the spatial optimization, meaning all the possibilities of water for conveying water from all the source nodes to all the demand nodes, we need to do a network optimization. And in that step, we are going to include the capacities of the desalination plants, the capacity of the aquifer, how much water goes into the river to distribute that water among the users.
Okay, thank you. Oh, Rick.
I don't see any online yet. No. I'm sure you said this, but I think I missed it. I was thinking, as you're answering that question, I was thinking about the changes in regulation that have been going on even in the last few years in Chile. And is the use of this whole system such that you can input and consider a whole range of different scenarios? Is that what it is, or is it for individual users? Or
it's for exactly that, just to look at regional scenarios and see what happened if this happened. It's exactly that. It's the way to plan ahead of what will happen and to have the optimized system to deal with that changes.
Thanks. I'm just going to, we have a question online here from Christine Charles. Fantastic work. I can see how this translates into much more engaged conversations about water decisions in Australia. Has there been dialogue in Australia with companies and regulators on this topic?
Not aware of that, but the final goal of this tool is to be able to be applied anywhere, actually. So this is our case study, yeah. So in the future, yeah, the aim is to make it available for everywhere.
Okay, thank you, Liliana. I think we'll leave questions there. That's excellent. Thanks very much for that. Fascinating.